Everyone, and welcome to a very unique and interesting semester, to say the least, at not only at Pacific, but I say actually across the world. We're going to be fully remote this semester, but I want to welcome you to actually what I hope is going to be an extremely fun semester, an extremely informative semester, and hopefully you can learn a lot about polymers, polymer physics, composites, and really about material science and thermodynamics that you could take with you throughout the rest of your academic career here at Pacific and hopefully beyond. Whether you go into a PhD or go into industry, I think that this class is going to be fun and you're going to learn a lot. So I'm happy and I can't wait to see you all on Monday. So right now we're just going to do kind of a brief introduction. Unfortunately, I think in this class, this class is actually modeled after the most difficult course that I took during my career as an undergraduate at MIT. So it's modeled after a course called 3063, which is actually polymer physics. It was taught by my advisor, Alfredo Alexander Katz, who is an actual genius, an actual crazy genius. So it is a very difficult course conceptually, to say the least. Also, he had a very interesting way of organizing the course as well. So I'm hopeful that I could kind of, again, I'm not going to be able to kind of capture like his genius, but hopefully a little bit more organization on my part to kind of lay out what's happening, and then that will really help you kind of succeed in this course. So, but again, I want to make sure that you understand at Pacific, this is the most difficult course that I will probably ever teach. It takes a lot of effort. So, but again, as long as you're willing to put in the effort, the previous group that I taught, they were unbelievable in terms of the dedication and the effort they put into this course. Almost all of them had A's. I really wanted to give the last person, they got a B plus. Unfortunately, they did a little bit not as well in the last exam as I was hoping that they would. But again, tremendous achievement for the really difficult topics that we're going to discuss. But I don't want to scare you off. Even though they're difficult topics, they're extremely fun. Polymers are my favorite material. They're the most interesting material. They're dynamic. They're kind of you always see this kind of as this kind of random coil or spaghetti type behavior. They're kind of almost always in motion. They're kind of conforming and changing shape. There's so many different types of architectures that we're going to see. Thermoplastics, thermosets, polymers are kind of an endless field of study, just in terms of the number of polymers that you deal with, much less kind of their unique properties. So you could spend a lifetime studying a single polymer, studying one type of behavior, and they'll always throw you for a loop. So polymers are fun. If you could study polymers, you could study any other material science. So everything else is easy. Polymers are hard, but they're fun and they're worth it. And there's so many different applications that we'll get into throughout this course. And really, we're going to be studying actually even more generally soft matter. So if you're a bioengineer in particular, you're going to hear me go on a lot of bio rants and how you could basically, we don't need biology, we could just simulate everything. Every biomaterial could just be simulated or modeled as a polymer. I know that's not true, but I kind of a little bit believe it. But but anyways, so in this course, we're going to cover quite a bit of topics. So the way that this course, this today is just kind of introduction on what you should expect to see in this course. So the big thing is P-sets and exams are really heavily weighted. So P-sets are about 40% of your grade. Exams are 60%. The exams are fairly difficult, actually really difficult, I imagine. But this semester, they're going to be completely open notes, open everything. You can use Mathematica, and you're highly encouraged to use Mathematica to kind of solve those problems, at least the quantitative aspect of it. But I think the big part about the exams, there will be 3 of them. Exams, there will be 3. 1, 3. And P-sets, generally, there's going to be probably about 8 P-sets. The key thing on exams and P-sets is explain. So these questions that I'm going to ask in MECH202, these polymer questions are going to be very open-ended, and you need to elaborate on your explanation. So when I mean elaborate, I mean several sentences, 3, 4, 5 sentences per question at the minimum. So you need to explain what's going on. There's lots of kind of questions that are, multiple questions asked in a single problem. So explain, show me your knowledge. You want to show off your polymer knowledge to me, and then I can know, okay, you understand what's going on. If it's a concise answer, and you hit all the points, that's great. But again, I need to see and understand kind of how you thought about this problem, how you visualize this problem. So that's kind of going to be the one tricks this semester. So while there's advantages in terms of open notes and open Mathematica that you can use on exams, the one difficult part of this course in teaching it is going to be, I use a lot of demos in class. So I'm going to try to record myself the best I can, but you lose a little bit of that in-person kind of nature. The other key things about my exams, you're going to have 90 minutes to complete the exam and 10 minutes to submit your solutions. My exams are very, very time intensive, and then you need to kind of really practice the pace of these exams. Even if you've taken other courses with me, this course is kind of a beast on its own. So we'll work on that together. Don't worry too much about it. We're going to have our review session. We'll have practice exams, and you'll kind of see what's the expectation. But again, the key part about this course, if you put in the effort and show me that you're working on it, you're going to be just fine. So don't worry. It's fun. It's worth it. Please stay in it. Believe me. So exams, there are going to be 1 through 3 exams. So we're going to start exam 1, basically cover lecture material, approximately lectures 1 through 7. So this is going to cover topics, very broad topics. So we're going to talk about kind of the basics like architecture and structure of polymers that you're going to see here. The next lecture will be a little bit of polymer chemistry. I know size chemistry is not fun. I don't know much about chemistry. I'm not a polymer chemist. I will show you some synthesis techniques. I actually do a little bit of chemistry, but it's if I told a chemist that I do chemistry, they would laugh in my face. So don't worry. No one's going to judge anybody here on that aspect of it. So it's no problem whatsoever. So we're going to deal with polymer chemistry. Then we're going to get into how we model chains. So we're going to talk about the freely jointed chain model. We're going to talk about the physicist model, the chemist model. We're going to start to talk about one of the key parts about this course. In addition to polymers, you need a strong materials background in this course, and then also strong thermal background. So thermodynamic wise, we're going to talk a lot in this class, and if you've taken a thermal course, I'm going to bridge the gaps because again, you might not have taken particular materials thermal course, and in this course, it's a little bit, again, it's kind of more of a physics, polymer physics-y course, and the thermodynamics might be different from what you've experienced previously. In terms of materials background, I can definitely help there. So I have a OER that is on the UOP website. So it is an open educational resource. It's basically a textbook that I wrote. So that is open to anyone. Just let me know if you need the link, and you could kind of brush up on your materials background there. So that's just a bit of an aside. So back to our exam 1. Should I even put here? Lectures 1 through 7. So polymer chains or polymerization. Then we're going to do chain models, polymer chemistry, chain models. We're going to get into a little bit again of thermo. So we'll talk about Florey-Huggins theory. Really interested to develop. We're going to essentially develop these phase diagrams. That's going to be a kind of a fun, but maybe conceptually difficult part of the course. And then we're going to get into the fun stuff, which is viscosity. Polymers are really cool. So depending on how fast or slow you pull the materials, the strain rates, they could change the mechanical properties. We're going to get into some techniques, size exclusion chromatography. We're going to look at osmometry, light scattering, all these kind of really cool techniques. And again, this is going to be where your exam is more focused on. So I'm going to provide a lot of background information, as you can see in these notes. Don't get too overwhelmed. We're going to focus in and narrow in, but just so you know, I love to give questions about techniques. I love to give questions that are graphical interpretation, and I'm looking again for I want to see the path that you're taking on the exam. I don't care necessarily, especially in this course, I don't care about the final number that you get. I want to see how do you navigate this problem? How do you break the problem apart? What approach are you doing? As long as you're following and you don't make any critical theoretical errors where you're just treating a polymer like completely differently than it should be, you're going to do fine in this exam. So the path to your solution, your thought process, that's the most important thing to me. Final answers, math, I don't care about that. You could take a course. This is not a math class. I assume that we know math or that we can use Mathematica to do math. So I really don't care about that at all. But polymer physics, polymer chemistry, soft matter, that's what I care about. All right, so that takes care of exam 1. Exam 2 is a little bit shorter in terms of lecture material, so it'll be lectures essentially 9 through probably 9 through 11. But again, don't be fooled by the number of lectures. Again, they vary in terms of length. So these are going to be topics, again, as broad as self-assembly, which, again, you could teach an entire course on. So a little bit of thermal again here. One of the key equations, again, hopefully you've seen this before, this will govern our class. Everything comes down to this Gibbs free energy equation. So the penalty, or we're always kind of this compromise between, we want to maximize entropy. So we want to maximize this guy. We want to minimize our enthalpic, so our energy contribution. So like this is kind of the energy due to bonding or some interaction where like molecules don't want to be next to other like molecules, et cetera, et cetera, et cetera. So this is the fundamental equation of our course. We're going to come back to this. You're going to be sick of it. Say, Professor Steimel, I know it. Why do you keep writing it in every single day? We're going to come back to this guy. And polymers are so much fun because, again, it's this, as you stretch the polymer, you decrease entropy, but you maximize these interactions. So it's this kind of always this competition between. These are always fighting. So we're going to figure out under what conditions are both of these satisfied, because we always want delta G, we want it to be as low as possible. Low energy, low thermal, the more negative we are in delta G, the happier we are as a system. So, back to exam 2, self-assembly. So we're going to talk about that topic. Then we're going to look at the differences between semi-crystalline and amorphous polymers. We're going to talk about TG, TM, techniques, DSC, XRD. So you can already see I'm going to ask lots of questions on these guys. And then finally, dynamics as well. Polymer dynamics, diffusion, kinetics. Really, really fun topics. I love the dynamics and kinetics. So that is exam 2. And then your last exam will be exam 3, which will be held during your finals week. Again, this is not a cumulative exam. I hated cumulative finals. You already taken multiple exams in other courses, or in my other exams, like why do you need to learn that again? But anyways, exam 3 will be held for lectures 12 to about 15, 16, depending on how far we get, how far I want to push you all. But again, I'm going to provide a lot of lecture notes, but a lot of it's, I want you to have these lecture notes so that you could kind of take this with you for the rest of your life. And if you ever have a polymer question, you could pull up MECH202 and hopefully the answer will be there somewhere. And hopefully I've written the notes where there's no errors. No, I'm just kidding. It should be fine. Typos, yes, definitely, but it's actually okay. 12 through 16 is all about mechanics. So polymer mechanics are really, really unique. So you probably dealt with, and we're going to cover, if you've taken my materials course, you've already dealt with elasticity, but we're going to get into kind of viscoelastic behavior, composites, composite mechanics, yielding behavior. Polymers are just so unique, so many different ways it can deform. Again, if you are an expert in polymer mechanics, solid mechanics or mechanics of metals or ceramics, other type of materials, I mean, they're trivial. So that will be exam 3. So that's what we have to look forward to the class. Again, I'm really excited. I'm so happy that we have quite a number of students in the class this semester. I think it's going to be extremely, extremely fun, and I'm really excited to working with you. And hopefully we can learn a lot of things together about polymers and do some really, really interesting work. So yeah, I think it's going to be a great semester. The biggest thing I want to kind of say out from the beginning is if you have any issues, whether it be with this course or personal issues or issues related to the pandemic and health, please, 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 please keep me informed. Let me know early if you're struggling. The best, if you let me know early, we can kind of address the issues. Unfortunately, if it's too late, really, if it's in that last week of classes, or even really if you don't come to me after exam 1 and you're struggling, it's going to be a little bit difficult to kind of recover and figure out a way and a path forward and some study strategies. So I'm always around for the most part. And I have 6 hours of office hours a week. So please, please reach out to me. Again, it's not, this is a really, really difficult course, so it will be completely understandable. So keep me informed, reach out for help, study hard, work hard in this course, and you're going to learn a lot, you're going to have fun, and everything's going to be okay. So yeah, with that, I will see you next time. We're going to actually get into the lecture material, and we will talk about kind of bonding, kind of hopefully a little bit of this is review from ENGR 45, so material science, if you've taken one of those courses. Hopefully it's a little bit of a review, so we'll go through that. fairly quickly, but there's going to be some new, hopefully nuanced things that are added as well. So yeah, I'll see you all next time. Thanks.